So previously we talked about being able to write an equation when we're given a set of data. All right, what I want to look at now is I want to be able to find an equation if I am given a graph. All right, so a lot of it is the same, but we're going to use a new method. We're going to make it pretty easy on ourselves. So let's take, for example, this equation right here. All right, so we have plot points on our graph now. All right, when we're looking for an equation from a graph, I know that I'm going to be writing a y equals mx plus b equation. And again, we've described what slope and y-intercept is. Y-intercept is where it crosses the y-axis, the up and down axis, and our m is slope, the rate of change that every 1x produces in y. All right? When we're doing this from a graph, however, though, we have a certain set of rules that we must follow. I personally prefer that when we're looking for an equation on a graph, I always go from left to right on my graph. All right? Always. It just keeps us from ever having a negative number on our run. And you'll see what that means here in a minute. All right? The method that I feel like is probably easiest when writing an equation from a graph to find the slope is a method that we call rise over run. All right? So what this refers to is if we start at our farthest left point, if we start on our farthest left point, which would be here, all right? We want to find out how much we need to rise, and we refer to rise as up and down, to our next point. And then we place that as a fraction over our run value. And again, if we always go from left to right, we should always be moving to the right. But there are special situations where we must move to the left. And this is called our run. All right, so it's pretty much just being able to count from point to point and filling out our rise over run. And this will give us our slope. All right, so let's look at this equation first. I start on my leftmost point. It doesn't matter what its value is. For rise over run, it does not matter what its coordinates are on this graph. We only have to know where it is. So we find it here, all right? What I want to do first is our rise, okay? So we're talking about how far do I need to go from this point up this graph to get even with my second point my next point to the right. So up by units we go 1, 2, 3. We can now see that my third rise is even with my next plot point dot here. So we would say that my rise would be plus 3, all right? So if our rise is plus 3, our slope would be filled out as 3 over something, all right? So now that we've risen 3, here's where we stopped rising. I want to go from this point to how far I have to go over to get to my next point, which we can see here is just 1 plus 1. So this is my rise, this is my run. I would put my run value below. So now we have the fraction 3 over 1, which we know that any number over 1 is that number. So this tells me that my slope for this equation is 3. Pretty simple. All right, so we would go over here to our equation, y equals 3x. Now, to find our y-intercept. This is also relatively easy with this method. All right? What we want to do when we find our y-intercept is we want to begin at the origin. All right? If you don't know what the origin is, that refers to where the x-axis crosses the y-axis at 0, 0. This is our origin right here. All right? If the y-intercept is where the graph crosses the y-axis, we should be able to go up or down our y-axis and find that number. So let's look. From our origin, we have a point that crosses our y-axis at positive 1, 2, 3. From 0, we had to go up 3, which tells me that my y-intercept is plus 3. Again, this is a relatively easy method for writing an equation from a graph, all right? There's not a lot of tricks to it. There's not a lot of anything. It's counting up or down and over and then counting up or down. The value of this on our y-axis would be our y-intercept. Up and then over is our slope, all right? So let's look at one more. Look at one more. Let's use this graph here. All right. So again, for the purpose of rise over run, it is going to be helpful to us to always start on the left and move to the right, as opposed to trying to go backwards, all right? So let's look and see if we can find the equation to this graph, all right? So let's start on our leftmost point. Our leftmost point is going to be right here. So we want to do our rise over run first to find our slope. Our rise comes first because it's on top. Now, last example, we had to go up 3 and over 1, which gave us a plus 3 and plus 1, correct? In this example, to get from this point to this point, we cannot go up. In fact, we must go down 1, 2. And you can see now that this dot that we fell to is even with this one. If we went up and got a plus, you would imagine that when we go down, this results in a minus 2. So our rise would be minus 2. And I know that when you think rise, you don't think going down, but our minus or negative actually means the opposite of. So this would be the opposite of rising 2, which is what we did. Then we look at our run. From our point that we fell to, 1, 2, 3. And you can see that as we go from left to right, my run continues to be positive. All right? That's why we go from left to right, so that our run value is always positive. You should never get a negative number on the bottom of your rise over run. This is not something that should happen. If you're going from left to right, your bottom number will always be positive. We know that in a fraction, if one of the numbers is negative, the whole fraction is negative. We also know that for the purposes of writing an equation, we need to leave our fraction as a fraction. We don't need to go to a decimal. So our slope is negative 2 over 3, 2/3, negative 2/3. Then we're going to go to our origin and find our y-intercept. Again, last example we went up, but here we go down 1, 2. So our y-intercept would be negative 2. Or, instead of negative, it would be minus 2. Alright? So again, this is a pretty simple method. If you're given a graph and asked what the equation of that graph is, we should be able to find it with relative ease. Alright, so this has been writing an equation when given a graph. Next, we'll look at when we write an equation if we're only given 2 points. Alright, so let's look at that next. Thank you.